After talking about the ideas involved in uh, single, singly linked list, in this video we are going to actually implement that in C++. So in Visual Studio, I have a source file that contains my main, and I included my header file, which I call linklist.h, and here's where I define my class. So let's start by defining class linklist. And the way that I'm going to define this is that the type of the data or the key, from now on, I'm going to call it data. I want that to be um, defined as a template. In other words, I want to define a class for linked list, and then when I'm creating linked list objects, I can create linked list objects that contain data of type int or char or any other type. So for that, the syntax is similar to what we did for our function when we were using templates. Um, so template type name t. So t is a variable for types that will be instantiated later when we actually create or declare linked list objects. Okay. Now, the first thing that, if you remember from the previous video, the first thing that we need to do is we need to talk about the node class, because a linked list is nothing but a chain of nodes linked together. So in the private section of this class, I'm going to define a class called node. And if you remember, this class has two member variables. One of them is the data, which we said it can be int or char, but now here I will say t data, and a pointer, which we call next, which will be pointing to the next node. So each node has a point, each node object has a pointer called next that points to the next node. So its type is going to be node star, and then I'm going to call that next. Okay, now here, since t may not be a built-in type and it may require a lot of memory, it's more efficient if we make it a reference, and even better if we make it a constant reference, so it cannot be changed. Okay, everything that we write here works if you just use t instead of constant reference, but this is just more efficient. Okay. Um, Now, finally, I want to define a constructor for this class where I provide the data, so constant t reference d, and then this constructor, when it's called, it creates a node where d is the data and the next pointer is null. So I say colon, and then uh, data should be initialized with d. So this member variable data is initialized with this parameter d, comma, the other member variable next is initialized with null. So it creates a node that the data is set to be d, whatever the argument is, and then the next pointer is set to null. And we are going to use this constructor when we're creating new nodes to be inserted into our linked list. Okay, now, if you remember again, we said that this linked list class needs only one piece of information, one member variable, and that is the head pointer. Because if you know the address of the first node, which is contained in head, then from the first node, you use the next pointer to go to the second node, and then from the next pointer in the second node, you go to the third node, and so on. So one member variable, which is a pointer to a node, and I'm going to call that head. Okay, so that's all we need in terms of the data. Now the rest is going to be defining member functions to give this class some functionality. Okay, so let's start with a default constructor, so linked list. Remember, a constructor is a function that is called automatically when you create an object of a class. And the name of the constructor is always the same as the name of the class. It doesn't have a return type, so we don't even put void for the return type here. And the default constructor is a constructor with no parameters. So no parameters here. And if you don't have any parameters, then the only kind of linked list that you can create is an empty linked list. And if you remember the previous video, from the previous video, we said that an empty linked list is a linked list where the head pointer is null. So the only thing that I need to initialize here is I need to initialize the head pointer to null PTR, and that's all the default constructor. Okay, so far there is no functionality, but I will be able to create linked list objects of different types because of the template. But I won't be able to do anything with them. But in any case, let's go ahead here and actually create a couple of linked list objects. So here's how, when you have a class that is defined using template, when you're creating an object, you have to, as I said before, instantiate T with an actual type. You have to say, okay, for this particular object, T is int, or for this particular object, T should be replaced with an actual type like char or string. And the way to do that is, after the name of the class, in angle bracket, you specify what T should be, what your template should be replaced with. Okay? And then I'm going to call this thing L1. And similarly, I can create another linked list object of type char. This time, T is replaced with char. Let's call that L2. Okay? And that's about it. These both are going to be empty linked lists, but one of them is capable of holding values of type int, and the other one for type char. Okay, now doing something more interesting, let's actually implement one of the member functions that we talked about. Let's do push front, one of the simpler ones. Okay, so here in the public part, if you remember, push front was a void function. So here I say void push front, and what I need here is a constant reference to T. Okay, so that's the declaration. Now I need to actually implement this. So I go outside the class, and if you remember, first we start with the return type, which is void, then the name of the class, the linked list, and then the T, and then the scope operator, double colon, followed by the name of the function, push front, and obviously the front. Now, since I'm using template here, before the name of the function, I have to specify that the template type name. Okay, now we're all set, and you can start implementing the function. Okay, this should be uppercase. There we go. Okay. Now, if you remember, first of all, we need to create a new node to be pushed to the front. So for that, I need to use the new operator. So I say create a new node, and then I know what the data in that node is going to be. Is this D here? So I call this constructor by providing the D here in parentheses. And if you remember, the new operator creates the object, set it up by calling the appropriate constructor, and then returns a pointer to this newly created object. So to store that address somewhere, I need a pointer, a node star pointer that I'm going to call new node. Okay, so new node here is going to be a pointer that points to the node that we just created. Okay. Now, to connect this to the rest of the linked list, I am going to consider two cases. Okay. Now, after creating this node, we need to connect that to the rest of the node. And this new node should be the first node. Okay. Now, we can do this in one case, but it's easier to understand if we divide this into two cases. The first case, if the linked list is empty. If you remember, the way that we know whether or not the linked list is empty is by checking to see if head is null. If the head pointer, which is supposed to point to the first node, is null, then it means that there is no first node, which means there is no node at all, which means that the linked list is empty. So in that case, what we need to do is we need to set head, which is supposed to point to the first node, which is going to be this new node, to new node. And that's all we need to do in this case. Okay, so now head is pointing to the new node, which is the first and the only node that we have, because originally before the push front, the linked list was empty. Otherwise, if the linked list is not empty to begin with, then what we want is, first of all, we want the next pointer in this new node, which by this constructor is set to null. If this new node is going to be the first node, then its next pointer should point to what used to be the first node. Okay, and the address of that previously known as the first node is stored inside the head pointer. So what we do is we say new node, our next equals head. Okay, so now the next pointer in this new node points where head points, which is the old first node. Okay, now the final thing is, remember, head must always point to the first node, right? Currently it's pointing to what used to be the first node, which is now the second. So I need to update head as well. And the address of this new node is stored in this variable, this pointer. So I just say head equals new node. And now head also points to the newly added node, which makes it the first node. Okay, that's it. That's push front for you. Now I can start here and say things like L1 that push front 12 and L1 that push front 3 and L1 that push front 5, right? And later on, when we define a print function, then we can print these, and then we can see that 12 is pushed to the front, and then 3 to the front, and then 5 to the front of that. So it will be 5 first, and then 3, and then 12 in our linked list called L. Similarly, for L2, I can push front different characters. So I can say L2 that push front the character D, and L2 that push front the character E, and so on. Okay, so that's push front. Now, because we want to be able to know whether or not things work the way that we expect them to, I'm going to define a print function. So void print. And what this function does is simply it just writes all the data from the first node, second node, third node on the console. Okay, so here we go again. Template, type name T, and then it's a void function. The name of the class is linked list. It uses T, and the name of the function was print with no parameters. Okay. Now here, what I need is a temporary helper pointer. I'm going to call temp, and temp initially starts from the first node. So I assign the value of head, which is the address of the first node, to temp. So temp, similar to head, is now pointing to the first node. And I use temp to traverse through the linked list. Okay, so what I do is I say while we have not reached the end, which means while temp is not a null pointer, do the following. Okay, so first print the data in the node that temp is pointing to. So cout temp arrow data, maybe put some space after, and then make temp point to the next node. And that is done with one line of code, temp equals temp arrow next. Okay, so What we are doing on this line is that, remember, at the beginning, temp is pointing to the first node because we initialize it with head. So now, on the right-hand side of this assignment, I say temp arrow next. And if temp is pointing to the first node, then temp arrow next is the address of the second node. And we are assigning that to temp. So we are assigning the address of the second node to temp, which means that after this assignment, temp will point to the second node. And then we go to the top, and if it's not at the end, we print out the data in the second node, and then we do this again, which means that temp will point to the third node, and so on and so forth. So after the while loop, we just print end line to go to the next line, and that will be our print function. So now I can go to my source file and say L1.print and also L2.print. As you can see, 5, 3, 12, and END. So you see that we first inserted 12 to the front, and then 3 to the front of that, and 5 to the front of that. So 5 will be the first, 3 will be the second, and 12 will be the third value in that linked list called L1, and similarly for L2. Okay, so it's getting a little bit more interesting as we add these member functions. So now, let's say we want to add another member function. And as you can remember from the previous video, there are plenty of options. But let's do something that works towards the end of the linked list. Okay, so we have push front. Now let's do push back. Push back. Here we go. And we have template, type name T, and then it's the void function. The class name is linked list using T, the scope operator, double colon, and then the name of the function, which is pushback. There we go. Okay. Now, first of all, we need to create a new node. So in that sense, it will be exactly the same as push front. So new node is equal to new node with D as the data. Okay. Now again, similar to push front, I am going to consider two cases. If the linked list is empty, so if head is equal to null pointer, and then otherwise, if it's not, do something different. Again, this is not necessary. You can do this in one case, but it's more clear how this works if we divide it into two cases. Okay, so if head is empty, if head is null, if the linked list is empty, pushback and push front are exactly the same. The only thing that you need to do is to say head equals new link. So in that sense, it's exactly the same as push front. Now, for push back, the story is a little bit, I'm sorry, for the case where the linked list is not empty, it's a little bit different. So what we need to do is we need to start from the beginning of the linked list and traverse all the way to the end so that we can insert this new node that we created at the end of the linked list. Okay, to do that, I need a temporary pointer that starts by pointing at the first node, just like what we did for the print function. And then I need a while loop that says while temp arrow next is not equal to null. So what we want to do is we want this temp to go from the first node to the second node, to the third node, to the fourth node, and so on. But we want this to stop when temp is pointing to the last node. Now, when temp is pointing to the last node, remember in the last node, the next pointer is null. So that's how we check this, okay? So we say while temp arrow next is not equal to null pointer, which means that when we get out of this while loop, when temp arrow next is null, which means that temp is pointing to the last node. So move it forward by doing temp equals temp arrow next until this condition is false, which means that until temp is pointing to the last. Okay, now temp at the moment is pointing to the last node. So I think it helps if we go to the whiteboard and actually uh, do a little picture there. Okay. So this is the head. Okay, and what we did first was we created this new node somewhere. I'm drawing it at the end, but it doesn't have to be there. And then we had this new node pointer that points here. And then we enter the data here and we set this to null, all of that, right? Then we define this temporary pointer, temp. And at the beginning, temp initially was pointing to the first node, but then we said temp equals temp arrow next, temp equals temp arrow next. And we stop when temp arrow next was null, which means that if temp is pointing to the last node, then temp arrow next is null, right? That's the condition of the last node in a linked list. So now temp is here. Now we want to make the connection, and we have to do that by some pointer manipulation. Okay, so the first thing that we need to do is that, so basically there is one thing to do, and that is this pointer, which is null here, should not be null anymore because this node is not the last node anymore. This one is. So this pointer, instead of being null, should point to what is going to be the last node. Now, first of all, how do we access this pointer? So temp is pointing to this node, so temp arrow next refers to this pointer here. And what should be the address stored in here? The address of this new node. Where can I find that address? In this pointer here. New node. So it's as simple as that. Just one line. Okay. Back to the code. And yeah, so outside the while loop, what we do is um, we say temp and next is equal to new. And that's it. That's pushback for you. Now, the final member function that I want to implement here is pop front. So removing the first node. Okay. So again, that is going to be a void function. Pop front, no parameters, and on the implementation side, type name t. It's a void function. Linked list t and pop. Okay. Now, if your linked list happens to be empty, if head is null, then there isn't any node to remove. So you can simply return, terminate, and you're done. Otherwise, what you do is the following. Basically, what we want to do is we want to deallocate the memory allocated to the first node, and then we want to do head is equal to head arrow next. So that head, which used to point to the first node, we're going to get rid of the first node. So we want head to point to the second node because the second node is now the new first node, right? So we're going to do this, but if I just do this, then I didn't deallocate the memory that was allocated to what used to be the first node. So I have to delete that. But I cannot simply do delete head because if I delete head, then I lose the address of the first node, which means I lose the address of the second node as well. So what I do instead is I use a temporary pointer again. Node star temp equals head. Okay. And then I do head equals head arrow next. So now head is pointing to the second node. And then I use temp to delete what used to be the first node, like this. Okay? And when you use delete, it's always a good idea to set the pointer to null right after. Even though in this case you are at the end of the function, it doesn't matter, but it's good practice. Okay? So these 4 lines are in the else part. I don't need to put an else here because of the return statement here. But yeah, remember the address of the first node in a temporary pointer. Make your head pointer point to the second node, and then use that address in the temporary pointer to deallocate the memory of what used to be the first node. And that's basically the pop